Today we will be completing the IGCSE February to March paper of 2025, Variant 1-2, which is a core math paper. I will be answering all the questions in the simplest way, explaining and showing working for each question. However, if you want more in-depth understanding of a topic, make sure to check out my mathematics playlist. So, without further ado, let's begin. As we can see, this is a non-calculator paper, so a lot of our marks will come from our working. Question 1 is asking us to write this number in figures. As we know from our understanding of numbers, the hierarchy of placeholders goes like this. Therefore, 20,000 will have a 2 in the 5th position followed by 4 zeros. Question 2 is asking us to write this number in a variety of ways. As we can tell, this number is a decimal, so to convert a decimal into a percentage, we must just multiply it by 100, giving an answer of 7. To convert it into a fraction, we simply have to know that any percentage is just that number over 100, so its fraction would be 7 over 100. Standard form will need us to convert the number into this form, where a is a number between 1 and 10, and n is a whole number. To create a decimal in standard form, we must use negative powers. Therefore, the answer is 7 times 10 to the power of -2. In question 3, to find the factors of 18, we would have to find all the numbers that are divisible by 18. Writing all the numbers from 1 to 18 will show that 1, 2, 3, 6, 9, and 18 are the only numbers that are factors. In question 4, we are asked to find the value of these three equations. Firstly, 10 to the third power is simply 10 times 10 times 10, which is 1,000. Secondly, the cube root of 27 is any number that, when multiplied by itself 3 times, gives 27, so that answer is just 3. Finally, 7 to the power of 0 is just 1. This is because any number to the power of 0 is always going to be 1. Question 5 is asking us to draw the lines of symmetry. These are any lines that divide a shape into identical pieces. Therefore, we can clearly see that there are only 2 lines of symmetry, which flow like this. Any other lines will not give us identical pieces. In part B, we need to shade one box that gives us a rotational symmetry of order 2. That means that when we rotate this shape a full 360 degrees about its center, we will find the object to look similar at 2 points. One at 0 degrees, and the other at 180 degrees. Therefore, if we were to look closely at the picture, we would find that square needing to be shaded is this one. Question 6 asks us to find the reciprocal of this number. A reciprocal of a number is a complete rotation of a number's numerator and denominator, simply by dividing 1 by that number. To do so, we would first convert this number into a fraction, which would be 1 over 4. Then we would divide 1 by this number, giving us 4. In question 7, this is a test of understanding operations. To solve this, we would need to use the acronym BODMAS, which tells us which operation to use first. From the acronym, we need to start with multiplication, so -6 by -3 gives us 18. This is because a product of 2 negatives is a positive. Similarly, 7 by 2 is 14. Now we can just solve the equation from left to right, giving a final answer of 32. In question 8, we are asked to write these numbers in order. The simplest way to do this is to convert all these numbers into a common form. In this case, it is easier to use decimals. To convert 34% into a decimal, we just divide by 100, giving us 0.34. The value pi is infinitely recurring but simplifies to 3.14. Similarly, 1 over 3 is also infinitely recurring but simplifies to 0.33. 3 can be left as it is. 3 over 10 is just 3 divided by 10, which is 0.3. Therefore, looking at all of these numbers, we can rearrange them into this order, remembering to change them back to their original form. Question 9 is a question of time and requires some basic intuition. The film lasts for 70 minutes, which when converted into hours and minutes, we get 1 hour and 10 minutes. This now becomes easy as we are working with a 24-hour clock. We simply add 1 hour and 10 minutes to the film's start time, which will give us 20 hours and 45 minutes, which is the finishing time. Question 10 asks us what the area of the shape is, given that each square is 1 centimeter squared. Since this is a trapezium, you could use its equation to find the area. A is 7, B is 3, and the height is 4, giving a final answer of 20. For part B, shading 50% of the shape would mean shading half of it, and since we know that 20 squares make up the shape, we would only need to shade 10. For question 11, we are given a true formula and are asked to solve the following questions. There are many ways to complete this type of question, but I will use the simplest way. For starters, it is important to understand that when we move a decimal point in any direction on the left-hand side, we must do the exact same thing on the right-hand side. Therefore, if we move both decimals of each number to the left, as shown in part A, we will have to do the same for the right-hand side, leading to our answer being 3.978. With part B, due to the change in operations and decimals, it is important not to get confused. In division, if we were to change the decimal of two numbers by the same amount, the answer would not change. This is because each number is being multiplied by the same factor, leading to the same answer. For example, both 20 divided by 10 and 2 divided by 1 produce 2 as the answer, even though the decimals have changed. Question 12 asks us to solve the difference of two squares using a given method. To solve this equation, we must use the same method, showing similar working. Firstly, we would find the sum and difference of 29 and 21, giving us 50 and 8 respectively. Then we would find the product of these two numbers, giving us 400. In part B, we are asked to find the volume of this shape. It is important to note that since this is part B of this question, it is recommended to use the same method as before. Therefore, what we quickly recognize is that we can locate two squares in this prism, one that has side lengths of 17 and another with side lengths of 13. Therefore, the area of this section is 17 squared minus 13 squared, which is the exact example we were given in part A. Therefore, the area of the shaded region is 120, and to find the volume, we just multiply the area by 100, which is 12,000. Question 13 asks us to convert liters into cubed centimeters. What we first need to understand is that cubed centimeters are the same value as milliliters, and 1 liter is equal to 1,000 milliliters. Therefore, 8 liters is 8,000 milliliters, and 8,000 milliliters is 8,000 cubed centimeters. Question 14 shows a triangular prism and asks us to answer the following questions. For part A, we are asked to fill in the gaps about the properties of the prism, such as its faces and its edges. These properties are easy to count and see, giving an answer of 5 faces and 9 edges. For part B, we must show that the length of BC is 5 centimeters. The easiest way to solve this problem is by understanding trigonometry. As we already know, using the Pythagoras theorem, the sum of the square of the two shortest sides is equal to the square of the largest side. Since line C cuts the triangle exactly halfway, this line is half of AB, which is 3 centimeters. Therefore, we can use the formula to find this length, which is simply 5 centimeters. In part C, we are asked to complete the net of the prism. To do this, we must simply cut along the edges in order to dissect each component. As we can see, the two triangles will lie here, with the remaining rectangles falling parallel to the base. Make sure that your measurements are correct. In question 15, we are given a triangle, and in part A, we are asked to define this shape. As we can see, all sides of the triangle are equal, and therefore, it is an equilateral triangle. For part B, we are asked to find angle Y through mathematical logic. Firstly, what we should know is that in an equilateral triangle, each line and angle are equal. Therefore, since a triangle contains 180 degrees in total, we need to divide this by 3 for each angle, giving us 60 degrees. Secondly, what we need to know is that the angles of a straight line add up to 180 degrees. Therefore, if we were to subtract 60 from 180, we would find that this y is equal to 120 degrees. For question 16, we are given a graph of temperatures and the number of people on a beach. As we can see, as the temperature increases, the number of people on a beach also increases, and this leads to an incline. which is known as a positive correlation. For question 17, the graph shows a line on a graph, and it is asking what the equation of the line is in this form. In simple terms, m is the gradient of the line, and c is the y-intercept. C is very easy as it is shown specifically on the graph as 3. For m, we need to use the rise and the run of the graph in the form of a triangle. In this case, we would use the rise of 4 and the run of 8, and using rise over run will give us 1/2, therefore, making our equation equal to this. For part B, we are asked to find the coordinates of P, given that it lies on the x-axis. Therefore, if point P lies on the x-axis, that means that there is no rise on the y-axis, and therefore, it is 0. So if we were to take the previous question and make y equal to 0, we could solve the equation. Take 3 to the other side to make it -3 equal to half x, which, when solved, will make x equal to -6. For question 18, we are given a table for an equation, and for part A, we are told to complete the table. This is simply done by substituting each x value to find the y value. Alternatively, part B requires us to jot down each coordinate and draw the line connecting each coordinate. Make sure that the line touches each dot or mark on the graph. Part C is simply just drawing the given line. This will be a horizontal line which passes the point -9. For part D, since each of the equations are equal, we must simply find the points where the lines intersect to find the x values. For question 19, we are told to write down numbers that satisfy the inequality. As is written, n is an odd number between 7 and 15, including 15 itself. Therefore, these numbers would be 9, 11, 13, and 15. For part B, we are asked to comment on Pip's statement. What's important to note is both the length of the line and the state of the circles on each side. In terms of his statement, he is correct about the length of the line, but incorrect about the circles. Since they are darkened, that means that they should be less or equal or greater or equal signs. For question 20, we are asked to complete the following statement about value h. This value is correct to the nearest meter, and therefore it requires an upper and lower bound. If the height h is equal to this value, then the bounds must be close enough to h that it gives this value when rounded. These two bounds will be plus or minus half of the margin of error, which is half a meter. Therefore, our bounds to h are 634.5 and 635.5 respectively. For question 21, we are given an algebraic formula. For part A, we are asked to solve for the value of x, given w and p. This is just simple substitution of values, which will then give x as 50. For part B, the question asks us to make p the subject of the formula. To do this, we need to take all these expressions and move them to the left-hand side of the equation. In order to do this, we must first understand that whatever we do to one side of the equation, we must do the same to the other side of the equation. So then, we must start by multiplying both sides by 3 to remove the 1/3. Then, we divide both sides by w squared to finally get p equal to this value. For question 22, we are asked to work out this equation. Since we have been given a mixed fraction and a proper fraction, the easiest way to solve this question is by converting the mixed fraction into an improper fraction like this. Then, we just subtract normally. The lowest common denominator is 15, so we multiply the 4 by 3, giving 12. Then, we subtract 12 from 22, leading to 10 over 15. Then, we can simplify the equation to make 2/3. In question 23, we are given a tree diagram and are asked to complete it. Firstly, what we must understand is that the probability of the battery being faulty, independent of any other battery, is 1 over 10. Secondly, since the total probability of an event must equal 1, then the probability of the battery not being faulty must be 1 minus 1/10, or 9/10. This is the same for all values on the second battery, as its faultiness is not dependent on the probability of the previous battery. For part B, we are asked to find the probability that Mi buys 2 faulty batteries. To solve this problem, we need to understand a simple rule. If we want the probability of one thing and another thing, we multiply the probabilities, while if we want to find the probability of one thing or another thing, we add the probabilities. Therefore, in this case, we must multiply the probability of 2 faulty batteries, which is 1/10 times 1/10, which is 1/100th. For part C, we are asked to find the expected number of faulty batteries, given that they sell 3,000 in 1 month. Since batteries have a 1/10 chance of being faulty, we must find what is 1/10 of 3,000, which is simply 300 batteries. For question 24, this is a question of understanding shape properties. The question states that a circle's circumference has the same length as a square's perimeter, given these conditions. Therefore, it is best to write these formulas down and solve them simultaneously. The circumference of a circle can be found using 2 pi r, and since the radius is 7 centimeters, we can simplify that to 14 pi. On the other hand, the perimeter of a square can be found using 4 times the length, and since length is x, the formula reads 4x. Therefore, if these two values are equal, then 14 pi is equal to 4x, and therefore x is equal to 3.5 pi. In question 25, we are given 2 mathematically similar triangles and are asked to prove a value. When 2 shapes are mathematically similar, this means that they have the same shape, but not the same size. Moreover, it also means that the ratio of their size is constant. Therefore, the ratio of these 2 sides is the same as these 2 sides. Therefore, the ratio of the triangles is 5 to 10 or 1 to 2. Therefore, to find QR, we must multiply 7 centimeters by the ratio, which is by 2, leading to QR correctly being 14 centimeters. Lastly, for question 26, we are asked to solve a simultaneous equation. There are many ways to solve simultaneous equations, but I will only show you 2 ways. The first way is by elimination. This is done by picking any one expression to eliminate, then solve for the remaining constant. For this question, I will choose to eliminate w, as it is easier. To do this, I must first make the coefficients of w equal. Therefore, I will multiply the first equation by 2 and the second by 3, giving me these new equations. Since w is now equal, I can eliminate it. Since the operations of w are different, we must add the equations together, leaving us with this one equation. Now we can solve for t, giving us 0.5. Using this t, we can place it into any equation to find w, which will be -3. For the second way, we can use substitution. This is achieved by making any expression the subject of the formula, then substituting it into the other equation to find the other expression. For instance, if we make t the subject of the first formula, we will get 11 plus 3w all over 4. Then we substitute this value into the second formula, giving us this. Once we have simplified this formula well, we will get a final answer w being -3. Then, once again, we will use that w to find t, which is 0.5. For clarity, once you have found your values, place them into one of your equations to see if they are correct. You can use any one of these methods so long as it works for you.